Welcome to Science 8 class. I am Debbie E. Alejo, your teacher for the day.
This module was based from the Department of Education's Most Essential Learning Competency number 2, Relate Laws of Motion to Bodies in Uniform Circular Motion.
Before we proceed with our lesson proper, let us try to evaluate your prior knowledge of the topic. For online learning, open your Google Classroom account or Facebook page and click the link posted by your teacher. For modular learning, get your printed module and open the pretest page. Write your answer in the answer sheet provided. You have 5 minutes to do that. In today's lesson, we are going to talk about the uniform circular motion.
At the end of the lesson, you should be able to describe uniform circular motion, explain how the first law of motion or the law of inertia is related to objects moving in uniform circular motion.
Before we start our lesson for this module, let's revisit the Newton's laws of motion and then answer the activity that follows. Do you know this person? Yes, he is Isaac Newton, and he is known for his famous three laws of motion. Now, can you tell me about these laws? The first law of motion is known as the law of inertia, which states that an object at rest will remain at rest unless an external force acts on it. And a moving object will continue moving in a straight path unless acted by an external force. Second law of motion is also known as the law of acceleration. This states that the greater the mass of an object, the more force is needed to accelerate that object. For the third and last law of motion, this is known as the law of interaction. This states that for every action force, there is an equal and opposite reaction force. Since we were able to recall and differentiate the three laws of motion, let us try to identify situations involving these laws. First situation, looking into the figure, a cup half filled with water is placed near the end of a plastic sheet. Pedro suddenly pulled the plastic sheet from under the cup. He observed that the cup remains in place. What type of law? Is it law of inertia, law of acceleration, or law of interaction? For the second situation, in a grocery store, a man is pushing his two carts. Cart A is empty while cart B is fully loaded with groceries. The man finds it easier to push cart A than cart B. What type of law? For the situation number 3, if you are driving in your car at a very high speed and it hits something, like a brick wall or a tree, the car will come to an instant stop, but you will keep moving forward. What type of law? For the fourth and last situation, when you dive off a diving board, you push down in the springboard. The board springs back and forces you into the air. What type of law? Have you been to a theme park before? Did you experience the thrill riding in a roller coaster? What about Ferris wheel? If not, have you seen images of how planets revolve around the sun? Can you think of other objects moving in circular motion? Draw on the space provided, or you can cut out and paste pictures or examples of objects moving in circular motion. Now, I would like you to consider and analyze the pictures you've pasted or image you've drawn. Try to answer the following questions. What is common among these examples? How are you going to describe the direction of their motions? What can you say about objects moving in circular motion? Are you ready for our first activity? Grab your pen, answer sheets, and look into your module. In this activity, you are going to describe uniform circular motion. Exploration 1 is entitled Moving in Circle. Study the illustration about an object moving in a clockwise direction around the circular path and answer the corresponding questions. What can you say about the speed of the object as it moves around the circle? What can you say about the direction of the object as it moves around the circle? What can you say about its velocity? Why do you say so? What can you say about its acceleration? Why do you say so? The diagram shown is an example of objects moving in uniform circular motion. What is uniform or what remains the same when the objects move in uniform circular motion? Use your understanding of the concepts of velocity and acceleration to answer the next four questions. Which arrow above represents the direction of acceleration when the object is located at point A on the circle? Which arrow above represents the direction of acceleration when the object is located at point C on the circle? Which arrow above represents the direction of the velocity when the object is located at point B on the circle? Which arrow above represents the direction of the velocity when the object is located at point C on the circle? Get your module and check your answer honestly. Let us define the following terms to better understand our lesson for the day. Centripetal force is the force that acts on a body moving in a circular path and is directed toward the center around which the body is moving. Constant speed is also known as the unchanging or no change in speed. Inertia is the tendency of an object to remain at rest or in uniform motion in the same direction by virtue of its mass. The law of inertia states that an object will remain at rest and moving object will continue moving in a straight path unless acted by an external force. Uniform circular motion can be described as motion of an object in a circular path at constant or uniform speed. As an object moves in circle, it is constantly changing direction. A race car moving in a circular path at 40 km per hour is an example of uniform circular motion. If the race car is in uniform circular motion, it means that its speed is constant or the same, which is 40 km per hour at every point on the circle. Are you ready for our first activity? Grab your pen, answer sheets, and look into your module. Activity 2 is entitled Whirl the Ball. In this exploration, you are going to explain how the first law of motion is related to objects moving in uniform circular motion. You will be needing the following materials. First, a 1-meter yarn of any color, rubber ball with at least 2 inches in diameter. You may use a basketball toy or a ping pong ball. Next is the plastic ice wrapper, which is 3 by 4 inches. And lastly, rubber band. Are you ready? Did you gather all the materials needed for this activity? So let's start with the first procedure. Please follow it carefully. Step 1. Get the rubber ball. If you do not have the rubber ball, you can use a ping pong ball as an alternative. Make a small slit on the ping pong ball or the rubber ball. Get a sand and put sand inside the ball. Then cover it and put it inside the ice wrapper. Another alternative is to put a basketball toy inside the 3x4 plastic bag. Do it now. Step 2. Tie the ball using the rubber band and connect the yarn. Step 3. Whirl the ball fairly and gently in a horizontal plane above your head. Be careful. For step 4, repeat step 3 to 4 times. Observe the behavior of the ball and its motion. Step 5, release the yarn. Observe the motion of the ball. Repeat this step 3 to 4 times. Were you able to follow all the procedures given? If not, watch the video tutorial instead. How was the activity? Did you enjoy it? Now, let's try to answer the following guide questions to help you understand the lesson better. Write your response in your answer sheet. Number one, is the force on the ball a push or a pull? Is it a push or a pull? Number two, what is the direction of force exerted by the hand or the string on the ball? Is it towards the center or away from the center? What happens to the ball when you release the yarn? How are you going to describe the direction of the ball? Using the law of inertia, explain why the ball behaves that way. Get your module and check your answer honestly. Great job! You have completed the activities. Take time to review and analyze your answers. This activity enables you to understand how the law of inertia is related to uniform circular motion. Take time to understand the following ideas or concepts for you to confirm the results of the activities you have performed. Newton's first law of motion states that an object stays at rest, or an object continues in its state of motion at a constant speed along a straight path unless acted by a net force. Hence, for an object to move in a horizontal circle, you have to pull the object inward towards the center of the circular path. So the force comes from the string that pulls the object towards the center of its circular path. This inward force pointing towards the center is called centripetal force. This force is needed for object to move in uniform circular motion. Centripetal force is not a new force. It only describes forces already acting on the body. It is the name given to any force like tension force, gravitational force that is directed towards the center. You will learn more about the centripetal force on your next module. This inward force pointing towards the center is called centripetal force. This force is needed for object to move in uniform circular motion. Centripetal force is not a new force. It only describes forces already acting on the body. It is the name given to any force like tension force, gravitational force that is directed towards the center. You will learn more about the centripetal force on your next module. Based from your activity, when the string was released, the ball fly off in a straight line tangent to the string or its radius. It's the ball's inertia that makes it continue in a straight line path. Let's consider the figure given. An object tied to a string is moving in uniform circular motion. the object is represented by the ball. When the string is suddenly cut, there is no longer net force acting on the object. The tendency of the object is to move in straight line, represented by the red arrow, not on the circular path, represented by the green arrow. Let's go back to this image and try to relate how a Ferris wheel demonstrates the concept of uniform circular motion. As the wheel turns, the cars exhibit circular motion because they revolve around a single axis of rotation, which runs through the center of the wheel perpendicular to the plane that contains it. The cars move around the axis with a constant radius, so they trace a circle as they move, since a circle is the set of all points equidistant from some central point. To describe the speed of the car, it is common to discuss the tangential speed because the inertia of an object causes it to try to maintain a straight line path. This is the speed of the car along the tangent line at a particular instant. If this tangential speed is constant, we will call this uniform circular motion. So what is uniform circular motion? Uniform circular motion is a specific type of motion in which an object travels in a circle with a constant speed, just like the concept in a Ferris wheel. The uniform circular motion of the car happens because of a constant centripetal acceleration towards the center of the wheel. At any given moment, the car has a velocity vector that is tangent to the wheel, and while the magnitude of this velocity will not change, the direction is constantly changing, and any such change in velocity can only happen due to some acceleration. Do you know that the uniform circular motion, as it relates to the first law of motion, can be used to explain why planet Earth stays on its orbit? The Earth stays on its orbit because the gravity of the Sun pulls the planet in. But the motion sideways keeps the planet swinging around. Without that sideways motion, it would fall to the sun, and without the pull towards the center, it will go flying off in a straight line as explained in the law of inertia. You're doing a good job. Now, try to answer these questions in order to summarize what you have learned in this module. Are you ready? How are you going to describe uniform circular motion? Write your answer in the answer sheet provided. The picture above depicts an athlete doing a hammer throw. Explain the relation of Newton's law of inertia to circular motion. Get your module and check your answer honestly. That ends our session for today. Do you have a questions or clarifications? Feel free to ask your teacher through chats or text messages. Thank you. Let us measure your understanding for today's session. For online learning, open your Google Classroom or Facebook page and click the link posted by your teacher. For modular learning, get your printed module and open the summative test that was attached on your module. Write your answer in the answer sheet provided. Now that you have summarized and understood important concepts about uniform circular motion as it relates to the Newton's first law of motion, let's extend your understanding a little further by answering the next task. Read and understand the situation below. Between Cardo and Aliana, whose idea do you agree with and why? Cardo and Aliana are out on a date. Cardo makes a rapid right-hand turn. Aliana begins sliding across the vinyl seat and collides with Cardo. To break the awkwardness of the situation, Cardo and Aliana begin discussing the physics of the motion that was just experienced. Cardo suggests that objects which move in a circle experience an outward force. Thus, as the turn was made, Aliana experienced an outward force that pushed her towards Cardo. Aliana disagrees, arguing that objects that move in a circle experience an inward force. In this case, according to Aliana, Cardo traveled in a circle due to the force of his door pushing him inward. Aliana did not travel in a circle since there was no force pushing her inward. She merely continued in a straight line until she collided with Cardo. Who is correct? Why?